Are gas calculations in stoichiometry confusing you? Well, let's fix that right now. I'm about to show you a method that solves any gas problem you can think of, and we're going to do it fast. You know how it is. You see grams, you see liters, there's a chemical equation, and it's just so easy to get completely lost. But what if I told you the solution is way simpler than you think? You just need the right tool in your toolbox. So that's what we're going to do. We're going to build a simple but really powerful strategy together. I promise, by the end of this, you'll be able to look at any gas problem and know exactly what steps to take. All right, let's get started. All right, let's dive right in. Now, listen up, because everything we're about to do, I mean everything, it all hinges on one single crucial concept. If you get this one idea, you are already halfway there. And that idea is the molar volume rule. So what is it? It's the molar gas volume. And the most important word on this slide, the one I really want you to focus on, is any. That's right, any gas. It doesn't matter if it's oxygen, hydrogen, carbon dioxide, whatever. 1 mole of any gas takes up the exact same amount of space as long as the temperature and pressure are the same. Pretty cool, huh? And here is the magic number you've been waiting for. At what we call standard temperature and pressure, or STP for short, that volume is always 22.4 liters. Let me say that again. 1 mole of any gas is 22.4 liters. You absolutely have to burn this number into your brain. It's that important. Now, to make this even easier, we've got this handy calculation triangle. This little thing is going to be our best friend. It's the key tool we'll use because it basically gives you the 2 simple formulas you need to convert back and forth between the volume of a gas and the number of moles. Let's break it down. So here's the crucial point. Look at the triangle. If you have the volume and you need to find the number of moles, what do? You divide by 22.4. See? Moles equals volume divided by 22.4. And what if you have the moles and you want the volume? You just do the opposite. You multiply by 22.4. It is literally that simple. These 2 formulas are all you're going to need. Okay, enough theory, right? Let's get our hands dirty and actually solve some problems. We'll start with the basics and then work our way up. Just make sure you watch the steps really closely. All right, problem number 1. This is a nice, straightforward one to get us started. We're given the number of moles, and we need to find the volume. So think back to our triangle. Which formula are we going to use? Yep, the one that solves for volume. Okay, look here. Step 1 is always to write down the formula. Volume equals moles times 22.4. Step 2, we just plug in the numbers, so that's 2 times 22.4. And step 3, you just do the math. Punch it into your calculator and you get 44.8 liters. See? Simple as that. All right, next up, problem 2. Now, we're just flipping it around. This time, we're given the volume and we need to find the moles. So, back to our trusty formulas we go. And again, it's the same simple steps. First, write down the formula. Moles equals volume divided by 22.4. Second, plug in the values. That's 6 divided by 22.4. And third, solve it. You get roughly 0.27 moles. You see the pattern here? It's the same core idea every single time. Okay, time for a real exam-style question. This one has a little twist. Notice what they gave us. We're starting with mass, 8 grams of sulfur, not moles. This means it's going to be a multi-step problem. And what's always our first step when we have something that isn't moles? That's right, we need to find the moles first. Let's walk through this one together. Step 1, convert that mass into moles. Remember, moles is just mass divided by molar mass. So 8 grams divided by 32 grams per mole gives us 0.25 moles of sulfur. Easy enough. Step 2, we need to use the mole ratio from the balanced chemical equation. Looking at the equation, the ratio of S to SO2 is 1:1. So if we start with 0.25 moles of sulfur, we're going to produce 0.25 moles of SO2. Okay, last step. Step 3, convert those moles back into the unit we want, which is volume. We just take our 0.25 moles and multiply by our magic number, 22.4, and that gives us 5.6 liters. Done! Okay, you're going to love this next one. This is a great shortcut. Look at the question. We're given the volume of one gas and asked for the volume of another. Now, because 1 mole of any gas has the same volume at STP, we can actually use a really cool shortcut here. The really awesome thing here is that we don't even need to calculate moles. Why? Because for gases at STP, the mole ratio from the balanced equation is the exact same thing as the volume ratio. So if the equation shows a 1:2 ratio between H2 and HCl, that means the volume of HCl will be twice the volume of H2. We just do 2 times 12, which gives us 24 liters. How cool is that? This little trick can save you so much time on an exam. So we've tackled a few different types of problems now. We've seen a basic one, a reverse one, a multi-step one, and even a shortcut. Now let's pull all of that together into one master plan, a universal strategy you can use for any gas question. And here it is, your 3-step universal strategy. I want you to memorize this. Step 1, no matter what you're given, mass, volume, concentration, whatever, your first job is to convert it to moles. Moles is always the central hub. Step 2, use the mole ratio from your balanced chemical equation. This is how you jump from the substance you know about to the substance you want to know about. And finally, step 3, convert those new moles into whatever final unit the question is asking for, like volume, using our multiply by 22.4 rule. That's it. That's the game plan, every single time. This strategy, this is your key. It's a reliable roadmap that will guide you through any problem they throw at you. But look, just understanding it isn't enough. You have to master it through practice. So take this 3-step process and do problems until it becomes total second nature. So from now on, the next time you see one of these stoichiometry problems with gases, you have a plan. You know what to do. Convert to moles, use the ratio, convert to the answer. No more confusion, no more guessing. Just a clear, confident strategy. So let me ask you, are you ready to solve any gas problem that comes your way?